Good everyone. Now today we're looking at vectors and we are going to explore the basic concepts of vectors. To start, we're going to look at a definition for vectors, and a vector is a quantity that has both magnitude, which is a size, and direction. Now, two important points to note is that one, the length of the arrow represents the magnitude of the vector, while the angle represents the direction of the vector. Now we're going to go into direction some more. And we're going to start out by looking at the direction based on geometric coordinates. And we are talking about our north, south, east, and west. Now let's take, for example, a vector is going along the northern path at 7 meters per second, which is its magnitude. Then we simply present this vector as 7 meters per second due to north. In a similar example, a vector is going along the western direction with a magnitude of 9 newtons, then we simply present this vector as 9 newtons due to west. Now we're going to look at another set of examples. And let's say the vector is between north and east. If the vector has a magnitude of 15 meters at an angle of 60 degrees above the eastern path, now, very important to note this, we present this vector as 15 meters at 60 degrees north of east. Why north of east is simple because the 60 degrees or the angle is closest to the east. So we'll write east last. All right, and another way to express this, we're going to look at the missing angle here, which is 30 degrees. So we can also state that this vector is 15 meters at 30 degrees east of north. Again, the 30 degrees is closer to north, so you'd write north last. All right, let's look at another example. If this vector is between west and south at 40 newtons at an angle of 18 degrees below the western line, how would you represent this vector? If you state 40 newtons at 18 degrees south of west, that is absolutely correct. Another way to say it is to look at the other angle, which is 72 degrees to make the 90. Then we say 40 newtons at 72 degrees west of south. All right, again, remember you write the direction that is closest to the angle. All right, so in the first example for 18 degrees, you state west last because 18 degrees is closest to west. And in the 72 degrees, it is closer to south. So you write south last. All right. So now look at another set of examples. In this set of examples, let's say we're going exactly between north and east at 15 meters. All right. So how do you state this? It's simple saying that is 15 meters northeast. All right. In a similar way, if you go between west and south, exactly between, which is halfway, 45 degrees, and let's say this is 40 newtons, then this will definitely be 40 newtons southwest. All right, typically another example here is 2 meters in exactly between west and north. So we're going to say 2 meters per second northwest. If you have another example, you could say this one. Let's put the quantity, which is 15 kilograms meters per second. All right, and so we're going to state this as 15 kilograms meters per second southeast. All right, so that's for the geometric coordinates. Now we're going to look at direction now based on bearings. Now some important points to note here is that north is the reference, which means all the direction will be taken from north. Directions are represented using 3 digits. So for example, north, it is 0 degrees. So therefore we're going to say 0, 0, 0 degrees. And what is important as well is that the direction is clockwise from the north. And so at the eastern position, it will be 0, 90 degrees. All right. And if you go to the south from the north, it will be 180 degrees. And to the west, from the north, it is 270 degrees. And if you go all the way back to the north, it will be 360 degrees or 0 degrees. All right, let's look at an example. Let's say we have 40 newtons and it is at an angle at 55 degrees below the western line or direction. How do we present this vector in terms of bearing? Is we can do a number of things. One, we can now determine our direction again from north, and then we look at the missing angles. So here, for example, will be 35 degrees, and then we know from the north to the south is 180. So we can calculate our bearing as 180 plus the 35, which gives us 215 degrees. All right. So again, 180, which is the south, plus the 35 gives us 215 degrees. Or what you can simply say is 270 degrees, which is here, minus the 55 degrees, which still gives us 215 degrees. So this vector based on bearing would be 40 newtons at a bearing of 215 degrees. All right, now we're going to look at direction based on the Cartesian coordinates or components. Now in the Cartesian coordinate system, what is important to note is that the positive x-axis is the reference. All right. What is also important is that direction are in 2D or 3D dimensions, which could give us x, y, or z components. What is important is that for the AP, CAPE, or any advanced physics, will really look at two-dimensional directions. All right, not until you go into college and go into deep engineering and doing other courses at your second level physics in college, then you may go to the 3-dimension. So, next point to note is that the position or the components are determined by 2 points, and these points are either, again, for general advanced physics, is the x-axis and the y-axis. The x-axis is represented by I, and the y-axis is represented by J. All right. Now the direction is anti-clockwise, again, from the positive x direction. And so let's take, for example, a vector is between the positive y and positive x. And let's say this is at a value or magnitude of 5 newtons at an angle from the positive x, 50 degrees. All right, so notice again, the direction is counterclockwise. All right, now we have an x component. You will also have a y component. So those are the 2 components of the 5 Newton force. Now let's say we shift another vector towards the opposite side. Now if it's at 6 degrees, again, we'll have our x component, and this time the x component will be a negative. All right, and now we also will have a y component of this vector. All right, so those are ways you look at vectors based on the Cartesian system. Now again, the angle for this vector, again, is counterclockwise from the positive x. So if you think about the angle above the 6 degrees, that will be 30. And so you know this side here is already 90. So the total direction or angle for this vector will be 120 degrees. 30 plus 90. All right. Now let's dive into the magnitude or finding the magnitude of the resultant force for 2 concurrent vectors. And this is also based on the Cartesian system. Now, we're going to do examples of this in another lesson. All right, so let's briefly look at something here. So let's identify the forces as, say, force 1 and force 2. You can actually name them different names like A, B, C, and whatever it is, A or B. So you can decide what you want to do. Now, the component forms for these forces, so let's say force 1 in component form will equal to force 1 in the x plus force 1 in the y. Again, x is I and y is j. For force 2, it will be force 2 in the I or x plus force 2 in the y or j. All right, and so a total in terms of the resultant now will give you the sum of the x component, which is the I, and plus the sum of the y components, which is the j. However, to find the actual value of the resultant component, what we're going to use is the Pythagoras theorem. And so as a result of this, what you'll get as a resultant first is the square root of the sum of I square plus the sum of j square. So what you're going to do here is to put all the x components together and find the sum of that and then square that, and you're going to add that to all the y components together and you square that, and then you find the square root to find the resultant first based upon Pythagoras theorem. Now, some very important rules to consider or to remember to be very good in vectors is one for the trig rule. And the trig rule is SOHCAHTOA. And so what you need to identify from any angle is the opposite side, the adjacent side, and also to know your hypotenuse. All right, so in this case, the hypotenuse here is C, the opposite side for this angle is A, and the adjacent side is B. Now, sine theta will give you opposite over hypotenuse, that is the SO. And then we have our cos theta, which is a cos the angle, is adjacent side over the hypotenuse. All right, so this is our ka. And then for our TOA, which is the tangent of the angle, is equal to the opposite side divided by the adjacent side. All right, so those are very important formulas for you to note for the based upon the trig rule. Now, let's say we have a vector of f, which is the hypotenuse in this case. Now, to find the two sides or the other two sides, we can use for the y component, fy, which is the component of f in the y component is equal to f times sine theta. Again, because that's opposite side and f is the hypotenuse. All right, so opposite and hypotenuse will determine based on your sine. Now, the adjacent side here, to find that side, which is the x component, then f times cos theta will give you that value. Now, based on Pythagoras theorem, if you want to find a side, in this case, we're going to find C, which is the hypotenuse, is given as C square, which is the hypotenuse square, equals to the sum of the two other sides square. All right, so that's a way to find any of the sides. And of course, you can manipulate the formula to find A square or B square, or simplifying in A or B. Now, looking at sine rule, and sine rule applies for triangles that are not right angles. And so what is important to point out first in the sine rule is that a triangle, you notice the angle, let's say take angle A, the opposite side will be side A. All right, and notice the uppercase and lowercase. So the lowercase is for the side, the uppercase letter is for the angle. Similarly, angle C opposite to side C, angle B is opposite to side B. So based on the sine rule, we're going to have sine angle A over side A equals to sine angle B over side B equals to sine angle C over side C. And these are just ratios of each other, so they are all equal. The inverse of this is also true, so we can also state that side A over sine angle A equals to side B over sine angle B equals to side C over sine angle C. All right, so they are ratios of each other. The reverse or the inverse is also true. Now, based on the cosine rule, now which is another set of rules that you need to identify and apply. And what is also important with these angles and side as well, we can find any side, and a side is given as that side square. For example, taking for the A, I want to point out something here. So the side A square is equivalent to the other two sides square. So notice the sum of the two sides square, which is B and C in this case, minus 2 times those two sides, which is B and C in this case, multiplied by cos the angle opposite to the side that you want to find. All right, and of course, you know, you can find the square root of both of the two sides to find A actually. All right, what if you want to find side B? Now for side B, it will be B square equals to the other two sides square, the sum of the other two sides square, which is A square plus C square minus 2AC multiplied by cos the angle that is opposite to the side that you want to find. In this case, it is side B. Now, similarly, for side C, it will equal to side C squared equals to A and B this time, the sum of those two sides, minus 2 times AB multiplied by cos C. All right, now, again, as a typical example, again, to find the side itself, which is, for example, the resultant in this case with the side C, all you need to do is to find the square root of both sides. So therefore, you say C is equal to the square root of A squared plus B squared minus 2AB multiplied by cos C. All right, so that's a way to summarize or actually find the actual value for a given side. You can do the same thing for A and B as well. All right. So at this time, we're at the end of lesson. I want to say thank you for watching. And also, please note that your effort and direction are important for your success. Have a wonderful and blessed day. Talk to you soon.